Hi, wonderful AP Statistics students. Welcome to another lesson in AP Stat Unit 1, Exploring One Variable Data. This is actually going to be our last set of notes today, Notes 10, where we are connecting raw data, z-scores, and percentages. So we're going to pick up where we left off with Notes 9, looking at z-score and percentages. We're going to see how our raw data kind of ties into that, and we can use some real world problems for that. And then we're going to talk about how we can actually work backwards from a percentage and find some raw data. And that's going to round out our normal distribution conversation today. So without further ado, if you're new here, I'm Goldie, and we're going to be diving into the set of notes at this moment. So first, raw data to percentages. Now, remember when I say raw data, I'm talking about the real world data. How any set of data, no matter what you are measuring, if we know that set of data is approximately normally distributed, we can fit it to the standard normal distribution, and we can find percents of the data that's going to fall within a specific range. So in our last set of notes, we went from z-scores to percentages. Now we're going to start this set of notes with an example of how we go from raw data to percentages. And we're going to use z-scores as our in-between step to do that. So let's say on a typical Saturday, Fiesta Market, our market here in town, reports that the mean amount of money spent by customers is $27.21, with a standard deviation of $7.93. We know that the distribution is approximately normal. What percent of people spend less than $20 at Fiesta Market? So this is the type of question we are going to be able to answer. So first, we're going to write the inequality using the raw score. Now, what I mean by that is we want to know this question: what percent of people spend less than $20? So it's important to get that question answered. So we're going to write it in a math notation first. So the percent of people, X less than 20. X represents our raw data here in this distribution. And 20 is also our raw data. That's what we're measuring in our distribution. So we want to know the percent of people that spend less than $20. So this inequality right here, this is just notation. Okay? We're not solving anything here with it. It is strictly just a notation that we are using to try to communicate what we're finding. Okay? What we want to actually find is the z-score. Okay? We want to find the z-score because we know that the z-score can help us answer this percentage problem. So let's find the z-score. Remember, z is x minus our mu, x minus mu divided by standard deviation. Okay? So our observation, meaning what we're trying to find, is 20. We subtract our mean of 27.21 and divide by our standard deviation of 7.93. We do that and we get negative 0.909. Okay, usually z-scores we want to keep to 2 or 3 decimal places at most when we are looking at these. Okay, so then from there we rewrite the inequality. Okay, now I want you to note that the differences between these two inequalities are important. Okay, it's important for your understanding. Okay, because they look very similar and because they're tied together. We want to know the percent of people spending less than 20. So this was this original data. What we did is we converted from X to Z. Okay. We just did a conversion. We standardized. So we have to change X to a Z. And that means our raw data, we took that and we standardized it and we created a Z-score. The inequality didn't change, but we standardized. Okay. So this is our new inequality that we are trying to find. We want to know what percent of z-scores is less than negative 0.909. Okay? And that's kind of where we left off at our last set of notes. We know how to draw this normal curve. So negative 0.909 is almost to negative 1, right? So we can draw our normal curve. We're going to shade the area to the left because that's what we're trying to find. And then what are we entering into our calculator? Remember, we're looking at normal CDF. Normal CDF. So that's second VARs on your graphing calculator to get those distributions. Number 2 is normal CDF. And what are we entering? Our lower boundary in this case, because it goes off here, our lower boundary is going to be negative infinity. Okay. Our upper boundary is right here. This is going to be our negative z-score, negative 0.909. Okay. So we're going to put those values in. Our mean and standard deviation, we're working with the standard normal curve. So mean is 0, standard deviation is 1. We press enter and we get a percentage of 0.182, okay, or 18.2% if you want to report it as a true percentage. Okay. But that answers our question. What percent of people spend less than $20 at Fiesta Market? Well, we can say confidently 18.2% of people spend less than $20 at the Fiesta Market. Okay. And those are the problems. That's it. That's what you'll be asked to do on some of these normal distribution problems. Okay. All right. So let's summarize what we just did, the process. Okay. So if you're a person that needs a process, here's a good table to help with that. So raw data, you have a distribution of data that's going to start with the mean and the standard deviation. You're going to convert your raw data, whatever you're looking at, whatever observation you're signaling out, you're going to convert that into a standardized score by subtracting the mean and dividing by the standard deviation. And this represents how many standard deviations above or below the mean your value is. Okay, right? That's just the interpretation of a standard deviation. And then to get the standardized mean, we have our mu set equal to 0. Our standardized standard deviation is 1. Okay. And we find the percent that corresponds to your standardized value using your calculator, specifically using normal CDF on your calculator. And then we use positive or negative infinity when we have unbounded endpoints. Okay. Now we use our calculator specifically. Some textbooks and other courses, they do still use tables. We used to use tables, I say back in the day, I'm aging myself here, but we used to use tables back in the day when we didn't have technology as available as it is now. Now we have our calculators, no problem. They can easily find this for us. So I'm not going to focus on teaching you how to use the table, but there is a table that's going to be given in your formula sheet for AP Stat that you can use to help you find these percentages as well. These percentages actually come from a little bit of the calculus side of AP statistics, where we're finding the area under a curve, which is an integral. So if you've taken AP Calc or you're in AP Calc, when you get to integrals, essentially what you're finding is an integral of the normal distribution function. Okay, so it's pretty cool. But because we don't know calculus, we actually can't do that calculation, which is why we have either the table or technology to give us that percentage. Okay, so we're not just kind of pulling these percentages out of thin air. It does come from a calculation, from a math calculation, but that math involves calculus, which is why we are just relying on our calculator to give us that percentage. And that way you don't have to use calculus to find it. Okay, you're welcome. All right. Okay. So that was the process of raw data to percentages. The last type of problem you're going to be asked to find is going the opposite way. Given a percentage, what's the raw data that corresponds to that percentage? Okay. And that's what I call working backwards. So for example, to show you this process, we're going to work through this example. Okay. On a typical school night, students get 7 hours of sleep with a standard deviation of 1.2 hours. Okay. Assume it follows a normal distribution. How many hours of sleep would a student need to get to be in the 75th percentile? So look at how that question is worded. How many hours of sleep? So when you say how many hours of sleep, we're looking for an X value, right? How many hours of sleep? Well, we're measuring sleep. How many hours of sleep? Okay, I need you to frame that in your head. We're looking for an X value. Would a student need to get to be in the 75th percentile? And percentiles correspond to percentages. Okay, so you're given a percent, 75%, the 75th percentile, 75%. You're given a percent, and you want to know the X value. Okay, step one is find the Z-score. Okay. Z-scores are going to be the in-between step for all of these problems. When we went from raw data to percentages, we calculated a z-score in between. To go from percentages to raw data backwards, we're going to calculate a z-score between. So we have to find the z-score that's going to correspond to the 75th percentile. So 75th percentile, remember interpreting percentiles is percent below. So we need 75% below. Okay. Now, is this going to be a positive or negative z-score, and how do you know? Right? Now, I just kind of phrase this question just to help you think about it, try to tie it into what we already know. Okay. Now, what we already know with the standard normal curve. Okay. So here's our standard normal curve. It's a curve of z-scores, right? Centered at 0, 1 standard deviation, out to 3. So we know that 50% is below the mean, and we know that 84% is below 1 standard deviation. Now, we know those percentages from the empirical rule that we've talked about. Now, when we look at 75% below, that kind of puts us between there somewhere, right? Not exactly in the middle, somewhere between. Again, the calculus involved, it's tough to know exactly where it is. Somewhere between there, though, right? So we know we're going to have a positive z-score, and that's because the percent we're trying to find 75% below, and that means that this z-score is going to fall above that 50% mark, which is our halfway point, okay? So that's how we know that it's 50% below, or 75% below, and that it's above 50, okay? Sound good? Okay. So now how can we get our z-score from here? Well, again, there's a few ways. There's of course the table that you can use. I'm just going to teach the calculator side, right? Because that's what we're using in here, truly. So back to that distribution. If you go to second VARs and get that list of distributions. I already told you we're not using normal PDF here. I'll explain a little bit more about what it is in the probability section, but we're never going to use it, right? We used normal CDF when we wanted to take a z-score and find the percent. When we have the percent and we want to find the z-score, we're actually going to use the next one, and that's inverse norm, or the inverse normal distribution. So I think inverse working backwards, right? That's going to be our inverse norm. So what it's going to look like when you click on it, it kind of depends on what calculator you're working with. Most of the newer calculators are going to have a screen like you see on my slides here. Some of the older calculators, if you have an older calculator, that's fine. They're not going to have this tail option, okay? Because what you have to put in here are 3 things. You have to put in area, which is the percentage to the left as a decimal. Okay, so that's the percent you're trying to find to the left as a decimal. Okay, now in the older calculators, you had to put in the percent to the left. Okay, it's always the percent to the left as a decimal. So in our example, if we're trying to find the 75th percentile, our area is 0.75. Okay. Now in the newer calculators, you have the option. It depends on where your tail is. If you're looking at the left, right, or if you're looking at the center. Okay. So I'll explain a little bit as we get into some other examples of when you can choose these other options. For right now, have the left tail highlighted, because remember in our standard normal curve, we're looking at 75% below. So 0.75 to the left. It's already to the left. The problem was set up so that we know the percent to the left. So we're going to put in area as 0.75. Now we're trying to find the z-score. So we're going to put in the mean and standard deviation of our standard normal, which is 0 and 1. Okay, so find your z-score by putting in mean of 0, standard deviation of 1. You press paste, and it returns the z-score. And I think you have to press enter one more time. But then it returns the z-score that corresponds to the percentile. And in our example here with our sleep, our z-score is 0.674. Okay. But we're not done yet. We found the z-score. Yeah. Now what do we do? Okay. Now that we have the z-score, how does this help us get back to answering the question of how many hours of sleep do I need to get to be at the 75th percentile? Okay, well, now that I have the z-score, step 2 is finding the raw data. So we're going to take our z-score, we're going to take our known mean and standard deviation of our distribution, and we're going to use the z-score formula to solve for x, our raw data value. Okay, so our z-score formula, remember, is this beautiful thing. So we're going to, our calculator gave us our z-score, and we're trying to find x. So we're going to put those values in. We're going to put the z-score we found, 0.674. We're going to put in our mean, and we're going to put in our standard deviation. Okay. We're going to solve for x then, which means, if you need a quick algebra refresher, right? Multiply both sides by 1.2, and then add 7. Right? And that's going to give us our x is 7.81. And that answers the question. So to be at the 75th percentile, you need to get 7.81 hours of sleep. Okay? And that's it. That's it. Let's apply this to a few other problems. Okay? Z-scores to raw data. Okay? Let's just narrow down this small portion, because you will just be asked to find sometimes this small portion of that larger problem. If we have a z-score of negative 2.3, a mean of 23, and a standard deviation of 5, what's our x value, right? You should be able to plug those into your z-score formula, and you should be able to solve for x, right? Pause the video if you need to, but your x value should be, drumroll, 11.5. Okay? You should be able to solve for that. Same thing with number 2. Plug in your values and solve for x here. Okay? Oops, sorry. This should be mean. And this should be, I think I had that on the last slide. Okay. Mean and standard deviation. Okay. And then percentages to z-scores. This is probably where I see students struggle the most with. So we're going to spend just a little bit of time on these examples. If you have 20% of your data lying below a z-score, what is that z-score? Okay. So remember, 20% below, it's very hard to determine. You could, with the empirical rule that we did earlier, kind of figure out what values it's between. But really, you don't want to do that on a problem. You don't want to spend time on that on a problem if you don't have to. So when I draw my normal curve and I estimate 20% below a specific z-score, I'm just kind of going to do a rough sketch. I don't know exactly if it falls between -1 and -2, where it's at. Just do a rough sketch, okay? You could figure it out. Remember, you could figure it out, but don't worry about it in these problems. Use your calculator. Right? Area to the left is going to be 0.2, mean 0, standard deviation 1. Put those values in your calculator, and that beautiful thing is going to give you your z-score, right? Not much you have to do besides knowing how to use your calculator. Okay? And keeping your head straight. Keep your head on straight. Know what you're trying to find. Let's say I want it above a z-score. If I have 34.5% of our data lying above a z-score, what is that z-score? Okay. Again, just kind of do a rough estimate here. Okay. The middle is 50%, right? So 34.5% is like here-ish, right? Ish. All right. What's that z-score? Okay. Now, if you have a calculator with a screen like this, you could put in 0.345. Okay. Again, it always has to be a decimal. Mean 0, standard deviation 1, and then you can click the tail to the right, because now we have our shaded region to the right of our normal distribution, okay? So you can do that, and if you press paste, you'll get your z-score right away, okay? Now, let's say you don't have the tail option, right? If this option is missing from your calculator, which it might be, it's only recently the newer calculators that got that. If you don't have that tail option, what you can do instead, you have to find the percent below that z-score. So we would take 100% minus 34.5%, and we would get the percent below that z-score, and then that is what we would put into our calculator is 0.655, since that's the percent below the z-score. Okay, so have the calculator that you're going to be using on the exam. This is why it's so important to get used to that calculator that you'll be using. Okay, like, yeah, you could find an emulator online or you could borrow your friends, but really you have to get used to the intricacies of your own calculator and what it requires. You know what I'm saying? Because you don't want to be getting a calculator on the AP exam for the first time and all of a sudden it doesn't have the tail option that you were used to. And then you're like, oh crap, what did Goldie say about finding percent below, right? Like, and you got to remember, no, get used to the calculator that you'll be using on your exam so that you know how to do stuff like this using it. Okay, that's my soapbox moment. I'll get off of it and tell you the answer is Z.4. That's your Z-score. All right. And then the last type is between. Now, between, you can't figure out the unequal, unsymmetric values. You have to have symmetrically in the middle in order to do these, in order to go from percentages to z-scores. There's really no other way without using calculus. So let's say if you have 35% of the data lying symmetrically in the middle of your distribution, what are your z-scores? Okay, so you are going to have that symmetric option. Okay, so what that means is you got 35% in the middle. What are your z-scores? Okay. So the way we would find that, again, if this is your screen, you could put in 0.35 and put in the tail as the center and then paste and you would get your z-scores. And it's beautiful. If you don't have that option, do a little bit of work, but it's fun work, it's fun work. And that's finding out what percent is below this z-score right here, which is if you take 100% and you subtract 35%, you get 65%. You get 65%. Now, 65% is on the outside, and because it's symmetric, that 65% is split evenly between the two tails. So if you take 65% and divide by 2, you get 32.5%. And so 32.5% is in each of those tails. So below this z-score specifically, you have 32.5%. So when you plug that into your calculator as the area to the left, you get a z-score of negative 0.45 right here. And because it's symmetric, the other z-score is going to be positive 0.45, okay, because of symmetry. So you find that first one first, and then first one first, and then use symmetry to say what the other z-score is. My favorite. So what calculator are you using, and get familiar with it so you know if you have to do this small extra piece of work in order to get those z-scores. Okay. And then the last one is actually very similar to the problem we did before here. Remember, percentiles, percent below. Okay, so if it's asking the 45th percentile, that's just 45% below your z-score. So put in 0.45 right away, area to the left, and you can get your z-score of negative 0.13. Okay. Now we'll put it all together. We're going to do, I think I have 3 examples to end this section of notes for us here. Okay, percentages to raw data examples. Okay, so on the most recent test, a student scored in the 40th percentile. The mean of the scores was an 85 and the standard deviation was 1.5. What was the student's score? Now, it doesn't say so in this problem, but and that's just because I was probably getting a little too sloppy. But we have to be told that these are approximately normally distributed. If we're not, then we can't really apply these percentages to a data set, okay? So I'm going to put it in here now. We have to assume that this is normally distributed in order to use it, okay? What was the student's score? So we're finding an X value. So we have to take that 40th percentile and we have to translate that into a z-score. So using our calculator, area to the left is 0.4. Standard deviation is 1, mean is 0. Our z-score is negative 0.25. This is also a good time to mention that I don't mind if you use calculator speak in your work for me personally, because I kind of like it. It shows me your thinking. Okay, but on the AP exam, since I'm getting you ready for the AP exam, I do have to say that in the free response section, they don't like you using calculator speak. And that's mostly because there's different types of calculators out there. It's just confusing when students are putting in a bunch of different types of calculator speak. So on the free response section, they used to take off points for you using calculator speak, but they don't do that really anymore. They don't take off points. They don't take off points as long as you're very clear about your labeling. So what you see here when I use my calculator speak, this is the type of labeling. If you were to write down something on the AP exam, you have to be very clear about what you're putting into your calculator. So you notice how I label it area, and then our mean, and then our standard deviation. Okay, I don't just write, this would not be good to write. Like, I just don't write that down, right? That doesn't really tell me that you know what you're doing. You have to be very clear about what you're putting into your calculator. Okay? If you were to write it down on the AP exam. The nice thing about the AP exam is you don't have to write down your work for that, okay? If you don't want to. If you come out saying that your Z is equal to negative 0.25, you do have to say what your Z-score is. So you do have to label Z equals negative 0.25. But if you put that down as a free response, as your answer to the free response, they're going to say, oh yeah, well, obviously they know what they're doing. They found that using whether it's the calculator or the table, and you'll be all set, okay? Try not to put down calculator speak on the AP exam, but I truly don't mind if you do it in my class. You'll have to ask, if you're not in my class and you're watching this video, you'll have to ask your teacher how they want it done. But I don't mind the calculator speak because I like it because it shows me what you're thinking. And then I can see, oh, they accidentally put in 0.6 instead of 0.4, etc. It's nice to see it. Nice to see the work. But once we get the Z-score, now we have to find our X because we want to know the student's score. So we plug it into the formula. We put negative 0.25 as your Z. X is what we're trying to find. Mu is 85. Standard deviation is 1.5. We solve for X and we get 84.6. So the student's score was 84.6 to score in the 40th percentile. Okay? Not too bad. If you want to pause this and try it on your own and then listen to me when you're ready to see the answer, by all means do that. Okay? We have 2 more examples here. Okay? Number 8, on another test, they only had 10% of their classmates score better than them. The mean was 76, standard deviation 2.2. What was the student's score? 10% better means that 90% was below. Okay, so you can put what you need to put in your calculator if you put 10% in the right tail or you put 90% in the left tail, right? Both of those options will give you the same Z-score. Okay, so put your head on straight, know which ones you're putting in your calculator to get your Z-score. I put in area to the left is 0.9, mean 0, standard deviation 1, gives me my Z-score of 1.28. I put that in, and I get X equals 78.8. So 78.8 was the student score where 10% scored better than them. Okay. Now, this is usually the point where students ask, okay, hey, Goldie, if I put in area of 0.9, why can't I put in the mean of 76 and a standard deviation of 2.2? What does that give me? Well, if you want to test it on your calculator, put in a mean of 76, a standard deviation of 2.2. What do you get? You get that 78.8, right? So you can actually answer this just using your calculator. Okay. Now, on a multiple choice question, go for it, right? If this was a multiple choice question, I said, what was the student's score? A, B, C, or D? If you just put in this in your calculator and come out with 78.8, perfect, done. And circle that question on the multiple choice and move on. However, on the free response question, on the AP exam, if this was, let's say, an AP exam question, which it might be like a little part of an AP exam question, right? Just like a part A kind of question, you do have to show your work. And showing your work involves finding the Z-score. and then using that z-score to find x. Okay. Not only that, I require it on these types of problems because it shows me you understand what you're doing. Okay. Your calculator, behind the scenes, your calculator is just finding your z-score for you and then changing that z-score into an x. Your calculator still uses z-scores behind the scenes. You got to understand what you're trying to find, or what you're trying to find, of course, but you have to understand how you are finding it. And that's by using z-scores, by standardizing, by using the standard normal curve. So I still want to see it. The AP exam still wants to see your work. So I need you to still show it. But yes, on a multiple choice question, plug them into your calculator and get out that answer. Okay. You can also use it to check your answer on the free response questions too. Fun fact. Okay. Last question. Last question. An auto dealer finds that the average price of a previously owned vehicle is about $8,000, and he wants to sell cars that appeal to the middle 60% of market in terms of price. So find the min and max price of the cars the dealer will sell. The standard deviation is about 1,000, and the variable is normally distributed. Very important to know. So drawing a picture, it's part of showing your work. Is it optional? I want to say not right now. I want to see you draw the picture because I want not only to help you understand what you are doing, but I want to make sure that you know where we're going with this. Okay, we have a normal curve. I want you to visualize that normal curve. Then I want you to visualize that middle 60%. Okay, and that helps you find, okay, so we have that middle 60%. Now we're trying to find the two z-scores that are that boundary, right? So 20% is in each of those tails. And again, what calculator are you using with your inverse norm? Okay, know how to find your z-scores. I use the area to the left of my first z-score, which is 0.2. A mean of 0, standard deviation of 1, gives me a z-score of negative 0.84. Okay? And because of symmetry, the other z-score is going to be positive 0.84. Okay? So those are my two z-scores down here. My two z-scores. All right. And then from there, okay, I can find my x value, but I have to do it twice because I have two z-scores and I need two x values right here. Okay, so my first x value, my lower boundary, my minimum price that the car dealer will sell, I'm going to use my lower z-score of negative 0.84. I'm going to put in my mean and standard deviation, and I'm going to solve for x, and that's going to be $7,290. Then I got to find my upper boundary. So I use a positive z-score, my mean and standard deviation up here, and I solve for x up here. And that's going to give me $9,222. Okay? So the dealer should price the car between $7,290 and $9,222 in order to appeal to the middle 60% of the market. Okay? All right. And that brings us to the end of our lesson here. Okay. Not only is it actually the end of the lesson, but this is also the end of Unit 1, exploring one variable data. So if you've stuck with me throughout this whole unit, or even if this is the first video you've watched of mine, I appreciate it. Okay. Thank you guys so much. If you have liked this video, please hit the like button. Even if you didn't like the video, hitting the like button, it kind of makes me happy when I see it pop up. So please hit the like button. Subscribe to my channel if you're interested in more AP Stat content, because the next time I will see you, it'll actually be moving on to Unit 2, which is going to be all about exploring two variable data. Okay, so thank you guys so much for watching, and I'll see you in that next unit.